I'm going to go through a number of things, and I would say kind of through these 5 areas that I'm going to talk about, kind of the scope of what's in discussion as we're looking at incident response and what an attack is. That's going to become an important conversation that we have later, the definition of an attack, the scoping, the gaps that we're seeing, the identification kind of maturity and variables, as well as the operational response. Much of that is irrelevant on what industry we're talking about, whether it's oil and gas, chemical, water, natural gas pipeline, or electric, and regardless of what kind of geography we're talking about as well. The last box on the regulation side, that is really only kind of 4 or 5 slides that is US specific and kind of North American specific due to the cybersecurity regulations that exist there. The one thing that I would say is there's also beyond our borders and kind of beyond our electric system, there's an entire ecosystem of people who work on that, support it, possibly own or operate elements within North America on the electric system side, or they're in the vendor community that is creating software, hardware solutions that support those assets. So even if there is regulation that is specific to North America, there's a tremendous ecosystem outside of North America that is impacted by those items. So without any more delay, we will get into scope of kind of what is in the universe that we're discussing here. Those who participated in the CTF, you've heard kind of Perdue Model references. You've heard a couple of references throughout our presentations on stage 1 or stage 2 types of attacks. An adversary kind of moving through these various network segments to get down into level 0 kind of sensors, actuators, or manipulating industrial control systems at level 1. We've shown you a couple of demonstrations of doing that, network-based impacts, as well as getting in and changing configurations of devices physically through wireless communications or near field, or getting in electronically over the network to reconfigure some devices, modify some logic, and make them kind of eat themselves and destroy the network from within. As we've referenced stage 1 and stage 2, the stage 1 element here, you see the little note on the bottom in super tiny script that that is trademarked from Lockheed Martin, kind of the concept behind the cyber kill chain. It has been expanded upon by Rob Emley and Mike Asante as they looked at that cyber kill chain and had discussions around it and started working on a paper. I had the benefit of being the behind the scenes guy that Rob was talking about to go through and kind of create some of these graphics and work on the elements that were going to be in that paper. And that paper is highly referenced throughout a number of SANS courses, throughout a number of different topics and conversations at industry presentations, because it expands on the component that is the Lockheed Martin cyber kill chain. This, as you see it, the reconnaissance, the targeting, the delivery, the C2, and the enablement kind of moving into the action phase. Again, looking at that kind of IT, data at rest, data in motion, or data in use, and what an adversary could do. The concept that Mike and Rob were really struggling with was, yeah, but even if they perform these actions top to bottom, that doesn't do anything to close a valve, to make the lights blink, or to impact the operational environment in any way. So they developed a stage 1 and a stage 2 of this kill chain that is specific to industrial control system environments. The things we're not talking about is all the stuff that really does just stay at stage 1. So all of the non-targeted, all of the IT, traditional malware, ransomware, intellectual property theft, general compromise and manipulating systems. That is not the scope of this DISC SANS ICS conference. There are tons and tons of industry IT related conferences. The piece that comes into play here is it's looking at those initial foothold and the initial compromises. It becomes a little bit cloudy in determining what is the intent of the adversary or the actor, and are they trying to simply move this stage 1 element so they can move beyond into stage 2. So that's where we start talking about some of these other items. So looking at an adversary that has achieved kind of stage 1 points of presence, however, they're using that as their launch point to begin to manipulate from the corporate, from these trusted networks, down into operational technology environments. Also attacks from partner networks. third parties that connect in, support vendor networks down into the OT segment, that again, kind of, you can't simply ignore the higher levels of the network, because that is generally where adversary from a remote, from a partner, from a third party, or from your own corporate will begin to do some actions and discovery in the earlier stages of stage one. Moving down into the environment further, again, looking at kind of the support services that are offered for patch deployments, for read-only data historians, for management and leadership view of operational performance and tuning, looking at maintenance and troubleshooting components that are up at that level, where they're pushing antivirus signatures down into an environment, or they're pulling logs out of an environment, kind of that four-legged firewall where you have a DMZ that handles egress traffic and you have a DMZ that handles ingress traffic into the lower levels of the environment that are secured higher. Those components of kind of stage one are in scope of what we're talking about from a OT incident response, because you will see a lot of these types of attacks targeting OT, some level of presence and DNA up in the higher level networks. Moving specifically into the stage two industrial control system elements, this is where this concept of gaining access and simply finding a vulnerability to exploit could simply cause a denial of service event, for sure. But if you have a specific effect that you're trying to achieve, you really need to spend some time living in that environment to understand how it's configured, how it's operating, what permissives and overrides are in place to allow you to do what you need to do based on the effect you're trying to achieve, and really, really understanding it, getting to a point where you can test and validate, and then ultimately working into the attack phases where you're delivering, installing it or modifying it as needed, and then executing that attack. This is generally where you'll see down into the environment more, at the facility environment, within the supervisory control and data acquisition networks, or across kind of plant or field remote deployments, depending on the communication networks. But you will also see highly targeted devices here, meaning an engineering workstation, which has all of the software generally that you would need to help build that understanding of the operational environment, has all the network communication paths, and in some cases the serial or analog communication paths down into the devices. So it becomes the pivot point that you can launch and do a number of things from. It also, when you're using that workstation to reconfigure or to understand or interact with those lower level devices, in many cases it looks normal. So it wouldn't appear as anomalous. However, if you were doing some level of kind of threat behavior analytics and seeing that the communications are coming from higher levels first into that engineering workstation, and then the engineering workstation is actively communicating down, that would be the component that you could potentially trigger on and identify. Using those devices to send and manipulate commands through the field devices and through the networks, also again, kind of at this stage too. Moving down into the devices themselves, if you're not getting to them from above, from the higher layer networks at the launch points, potentially having some supply chain issues, either on the build, on the ship, on the support, integration and operation. A number of things are kind of being talked about around the world in this, this phase currently, especially when additional communication channels exist. Looking for those exploits, potentially trying to cause a access event, a denial of service, or specifically manipulating what the device is doing based on system conditions. Ultimately looking towards kind of some of the attack campaigns that have been talked about here that are specific to our industry, whether it's Ukraine 2015, 16, 17, Trisis event, any of the non-targeted events that had some operational impacts. That's truly where you start to see some of this combination attack that gets very, very scary for a lot of the folks on this call. Finally, kind of the sensor to sensor, Jeff had demonstrated some ability to go in and modify some scaling factors on devices directly to manipulate how they operate within an engineered and designed system that could cause some issues, modifying them through the data tables of the industrial control system devices that they're connecting to. So you're not necessarily touching the logic itself. You're not necessarily manipulating these sensors or these kind of digital assets that are deployed throughout the field. And you're not manipulating anywhere on the network communication paths either. you're causing that manipulation within the device. Again, kind of looking at this model, you have to say, how did they get to that device? And if 95% of that time they're getting that device through the network, then I would spend 95% of my capital budgets, O&M, and my workforce looking at that spot. If there's a smaller interdiction element in supply chain or risk of a vendor integrator being manipulated, intentional or unintentional, in causing those effects, then I would spend less budget, less kind of focus your resources where the risk is. So that's kind of the scoping of what we're talking about, which is pretty important as we move into the gaps, as we look to the gaps specifically. So again, we're not talking at the IT levels here. We're talking about the IT into OT, or we're talking about the OT specific. So in these two kind of timelines across, let's walk through the top one first. It's really just a review of the two multi-stage ICS kill chain that we just walked through. So from a stage one command and control component, moving into that kind of industrial control system environment by escalated privileges, taking advantage of trust relationships, and getting into that stage two capability development at this element, working towards attack validation, working towards attack delivery, making any necessary adjustments and modification, and awaiting an execution point. Down here, kind of the defender actions. So the common IT security controls that exist, whether you're ISO, whether you're cybersecurity framework, whether you're NIST, whether you're any of the things that you heard about from Jason Christopher earlier this morning, all of the things down here within the corporate IT business network environments that in many, many cases through a targeted attack are doomed to fail. There will eventually be a method to gain access at the higher level networks if it is a targeted attack. Additionally, kind of traditional ICS perimeter controls, again, targeted attack, and given the amount of time of some adversaries within an environment, being able to find a trusted communication path or find a way in is truly a matter of time as they continue to map some of those perimeter controls. And in many cases, those perimeter controls are routers with ACLs or something that are with current tools and capabilities of some adversary nation states and threat actor groups. It is definitely a path in. The traditional kind of ICS asset hardening and controls, to the degree that they are available, it is a question of whether they're being used and implemented by the asset owners and operators. And in many cases, the devices are built for purpose device, meaning taking any cycles away from the real-time operating system to do packet validation or security components. Many of these devices are built with the expectation that they will be secured around the device physically and electronically. They are not built as a security device. Moving towards kind of situational awareness and data protection, again, you're working across a lot of different stakeholders in this space. Their awareness of ICS, industrial controls and process environments, plus cybersecurity capabilities, threats and vulnerabilities, plus operational knowledge, plus kind of monitoring and threat hunting and detection. You're asking a lot of people to have a lot of knowledge in this space, so easy for things to get missed. And a lot of these environments are unmanned, unstaffed, so it's difficult. You hit a point where if you've made the investments and kind of you're looking, if a tree fell in the forest, I know this comment was made earlier today, if you're looking and if you're listening and you actually detect something, now you start moving down the path of, is it an incident or is it an event, is it a misconfiguration? You declare it. Then you move into kind of containment and eradication, where you start to find what is the risk of operating in contested territory and decisions that need to be made within some operational environments. Are we putting the physical assets at higher risk by doing unscheduled shutdowns and unscheduled maintenance so we could perform the containment and eradication? Or is it lower risk to leave it compromised or contested depending on what the particular malware is? And that's putting a lot of responsibility on the team that's making that decision, that says, oh, this is just configure, it's only going to do X, Y, and Z. Making sure that they are signaturing that correctly and they understand the intent and they understand that that is all that's in the environment. The fact that you've discovered configure in your environment should be an indication that there's probably other things there. So making that risk assessment that it's just configure, we're going to continue to operate contested, that should definitely be challenged. Moving into recovering operational integrity and kind of getting back to this true mode of operation, the real point here is kind of looking across these kind of compromise to detection gaps, looking across the detection to containment gaps and the containment to remediation. These are all things that everyone on this call needs to focus on and say, how can we make these gaps shorter? How can we reduce adversary dwell time in these environments? Because the longer they're there, the more capabilities they will develop for a stage 2 attack. Moving towards identification, we have about 20 minutes left, so we're halfway through. Moving towards identification. So this is an area where historically there has been lots of gaps. I'm going to highlight a couple of things here. This is a slide that I used in a presentation that Rob and myself did a couple of weeks ago. But mainly what I want to talk about here is just this history of, in a lot of these environments, there was only capabilities to do collection on hosts, to do some level of analysis and do some level of detection. Over time, kind of system vendors and the network infrastructure within these deployments, we started to gain the ability to have network tap capability and limited port spanning within some of the industrial switches, where you could kind of pick 1 or 2 ports that you were going to monitor and that was it, without kind of making the original equipment manufacturer nervous that you were overloading the backplane and you may miss a scan or miss an important operational data transfer that could potentially cause some issues with the equipment from a safety or reliability event. And kind of doing some of these higher level cybersecurity detection capabilities many, many years ago would immediately start having discussions around safety and warranties. Now we've kind of progressed into a model where if you are running on newer systems, newer meaning in the last 10, 12 years, you're past this point of limited span and you have some visibility and you're moving towards kind of more robust capture, real-time network collection. You likely are starting to see so much data that now you have aggregation nodes and multiple collectors. And someday you may move into an integrated SOC where you're looking at IT, OT, operational alerts, and physical alerts, and really trying to take that data set and push it back down to the operators of your process so that they could use that information in their decision making. Along the lines of, from an electric sector perspective, they're looking real time all the time at all of their system telemetry, but they're also very interested in other data feeds like temperature, humidity, storm tracking, that they will begin to take that data set and inform their own operational decisions. To say, based on storms coming through or based on system capacity or based on X, we are not going to do the planned work that we were originally going to do, taking a unit down or ramping a unit down or doing line maintenance. Eventually, in kind of the Shangri-La world, you know, everybody's sharing data. You would eventually get to a point where operators are saying, based on the cyber alerts and the cyber activity that we're seeing at that plant or at that substation or at that compressor station, we're going to move to conservative operations and not do performed work, not do kind of scheduled maintenance, and until we resolve the matter and we investigate it. To get to that point, you have to have a lot of steps to get you there. And that would drive and be specific to each entity, looking at their existing capabilities. Is it something that they have a couple of people on a team that they're going to add this responsibility to? Or are they going to add some minimal staff or really expand out their staffing levels? And based on kind of that XY axis, that would lead you towards what tools and what solutions might work in your environment. So simply taking data sets and running a bake-off against 20, 30 different companies and saying this company saw more of this or this company saw more of that, that's not going to be directly relevant to your environment unless it's your data sets. And you also have to decide what you're trying to detect and how many people and how many data collection points you will have in the real world when you go and deploy it. Otherwise, you may very well likely find yourself selecting a tool, deploying that tool, and then being very unhappy with it because of your own capabilities on this axis, how much data you're seeing and what you're doing with it, and your own capabilities on this axis based on your staffing levels, the training that they have, the tools, and how you're architected. So kind of looking across these different tool categories of network whitelisting, threat behavior analytics, and anomaly detection, I'm not by any means saying one approach is better than the other. I'm saying based on where entities are currently and what their current investment from resources and what that balance looks like, you may find yourself that the smartest thing you could do is look at network whitelisting because you don't have any staff and you barely have any data sets. As you move forward in a more kind of capable environment with dedicated teams, you may find threat behavior analytics is the place to be and to live for some time. If you have very specific threats and needs, and you have a tremendous amount of data that needs to be looked at, a system that needs to be tuned, you really, really need to fully understand your operational environment with full collection across the board, and you have lots of people focused on this and working on it. If that is the level of risk of your environment and you have all those capabilities, then you may move up to some other tool sets. Looking towards kind of the adoption of this, we've had a couple of trend lines here. First being the just growing, ever-growing digital assets within industrial control system segments across from the early to mid 80s to today. Looking at the industrial control system protocols and moving away from kind of proprietary protocols into traditional protocols. And we saw sort of a dip in regards to kind of traditional routable protocols in some industries like the electric sector, because there was some regulation that was specific to if it's non-routable protocols, then certain requirements don't apply. So you actually saw some companies tearing things out for a period of years here in this dip and moving more towards analog and serial. And then you saw a new paradigm of those standards and regulations come that really made some of that work limited in effectiveness for regulatory reduction or completely irrelevant in other cases. Along the same lines, you saw that same trend with remote access. You saw a dip, and kind of with detection, you've seen it lagging for a number of reasons, whether it be one vendor is not fully warranting or providing access, or the network infrastructure equipment hasn't been upgraded or modified, or you've got deployed environments where you have multi-vendor solutions operating and getting kind of everybody singing on the same song sheet in regards to what the asset owner wants to do takes time. The piece that is of growing concern to me is all these arrows here. In the COVID timeframe, a tremendous amount of critical infrastructure started adding remote access capabilities at a much more alarming rate than what would have normally been planned, deployed, tested, validated, ensuring where people are remote connecting from and ensuring those assets meet certain criteria and they're in a managed way. And because of that strong movement rapidly, we need to start seeing that rapid trend line for detection also going up. I don't know that the world is going to go back to I don't know that this trend line in gray for remote access is going to dip down once people start returning back to work and kind of the global pandemic heightened levels of crisis start to reduce. I don't know that you're going to see this kind of shock back to the way it was pre-COVID. And if that is true and that's an accurate assumption, then we need to see the same rapid growth and adoption of detection capabilities as well to meet it. Moving into the operational response component here. Thinking about this from kind of the operators at these plants, at control centers, kind of whether it's control centers or control rooms or just operational personnel, and looking across these kind of attacker objectives of causing loss of view, loss of control, or moving into denial of view, denial of control, denial of safety, and in worst cases, kind of manipulation of view control. So if this is an attacker objective list and options within industrial control system space, this is more of a kind of aligning that to operator current capabilities within the sector. Currently, the existing emergency operation orders, general orders, kind of planned procedures that operators have at the ready are generally fairly well defined plans for a loss of view event or for a loss of control event at a smaller scale, a couple of sites or a couple of units or a couple of parts of the process, and for shorter periods of time. They are fairly well defined and prepared for that type of event. When you start to see kind of the denial component, that's when the plans generally don't completely address the events when the systems are available, but they don't perform the functions that the operator is requiring of them or expected of them to do. That's generally where things start to get harder for an operator to do their job that they've been trained to do for years or decades. Moving into the worst case is, this is the piece that we saw with Ukraine 2015 and Ukraine 2016. In going back from that incident response, working within asset owners and operators across North American electric system and other countries, is the final component. The plans definitely, and the training of the operators definitely, do not address the events when the system is available, but someone else is in control of it. And that is kind of our biggest challenge as we look forward to incident response and operational response and the preparation phase of that, in training the operators in how to manage and maintain their system in a way and move towards an integrity level when someone else is in control of it. So how quickly they can detect it, how it can be designed and engineered to prevent a catastrophic effect even when there's a successful attack. Looking at this operational response, so taking kind of the traditional IT preparation, identification, containment, eradication, recovery, and lessons learned phases of an incident response action, but looking at that from an operational perspective as well. So the system operators that are in control of your process or of the electric system or the natural gas or refinery or chemical, they're continuously trained to ensure system reliability and how to respond to emergencies. When storms come through, when terrible things happen, how can they be prepared and respond? The cyber operators supporting all of those underlying technologies, all of us, we need to be trained in the same way. And we need to integrate those individuals and knowledge areas into a common response. Best way to do that I've seen throughout my career is kind of this practicing IR through exercises, and not training the individual, but training the team. And doing that at large scale within your group, then within your organization, then within your industry, then across kind of the sector where you support. On the identification side, this ties back to earlier slides where looking at your capabilities of consuming that information and level of workforce and team available to kind of respond. So really understanding your own risk and what levels of evidence acquisition and analysis that you need to enhance, or looking at external information feeds from providers, managed service, or industry information sharing and analysis centers. On the containment side, thinking about the attack from the effect. So looking at what was done or what is currently occurring that you're aware of, and then walking backwards and saying, where would an adversary need to be in our operational environment in order to do what they're doing? And being able to quickly isolate that system or those components in a way that will provide some level or capability for you to isolate that control. On the eradication side, truly this is an area where you just continue to move back and forth between containment and eradication, because there's a general tendency and trend to celebrate wins, meaning we found Configure. At the next scheduled unit maintenance window, we got rid of Configure off of all assets. All units came back up. It's been eradicated. It's been contained, and everyone's happy. The recovery is done, and the lessons learned marches ahead. The piece that is really the question of, you identified Configure, meaning Configure got into that environment. Did you identify how it got into that environment? And are you sure that's the only thing that got into that environment? So ensuring that root cause or initial infection point is really, really important. Otherwise, you're going to continue to think you're having additional incidents when you never really resolved the first. Moving towards recovery, again, this is something that exercises will really, really help, but focusing on regaining integrity of the control system is probably the most important component. Recovering individual cyber assets, recovering individual digital components, as we've seen in Ukraine 2015, Ukraine 2016, any kind of misconfigured device or a device failure, In many cases, there is capability to move to manual operations and to continue to provide a reliable, resilient system or product to customers. But regaining the integrity of those cyber assets could be a very, very long road. Lessons learned, again, feeding into information sharing and ensuring that you are actually learning lessons, not just observing them. So you observe that an attack did this and caused this effect, but what did you learn from it that is actually going to prevent it is key. Looking at general operations, part of one of the roles that I had in a previous life was training system operators, not providing the training directly, but being in charge of that training program and watching kind of what they had to do for continuous education, using simulators, using dispatcher training environments so that they could practice the way they play. We could capture storms, we could capture a number of different things, replay them for the operators, and then they could walk through how they would have responded. The planning and analysis that goes into system operations on a daily, hour-to-hour basis, absolutely key. Looking at kind of their ability to shed load in an electric system environment so that they can maintain some capability to service customers and they could rebuild from. Emergency operations, this capability to kind of, we're all running one shared system, critical infrastructure, key resource, sending workers from one environment to another to assist, and looking at when it all goes down, having very specific asset capability to rebuild from. So in an electric generation perspective, commonly referred to as black start, having the ability to start a generator and be able to provide power through a cranking path to bring up other generators in that system. The reason I bring this up is really all of us in the industrial control system world are here to support operations, and looking at how operations has learned and developed and grown over years, we should learn from them. We should do all of these things that they're doing, add the word cyber in front of it, and that is what we should be doing. Cyber contingency analysis. When this device fails, what is the next greatest contingency that will inhibit us from providing the service we need to provide? Cyber failure planning, conservative operations, the ability to do cyber load shed, where we could sever based on a system condition or a level of an incident, what systems are able to talk, what trusted paths are engaged, and have a variety of different rule sets to call in based on the current understanding of a situation. Cyber black start, kind of thinking along the lines of, if all of your systems are down, including your systems that have your backups on them, what assets will you use to recover from and begin to operate again? And cyber mutual aid, kind of the thousands of people on this call and the industrial control system cybersecurity community that we are all part of, the willingness and ability for us to share lessons learned, share information, and help each other has never disappointed me that everybody is generally here for all the right reasons and very, very mission focused. The last element, and I only have a couple of minutes left, will be regulation. So for those of you not in North America, for those of you that don't care about electric sector, I only have 4 minutes left, so it's not going to bore you to death. But again, there are many other countries, many other parts, not just asset owners and operators that are impacted by this. I believe in one of the earlier presentations, there was a discussion about the importance of definitions. And here there are actual regulatory definitions. While they may not be the best, they are better than anything we had before out of the electric sector, and they are better than most other sectors who do not have regulation for cybersecurity. We do have these definitions now. Previously, asset owners and operators were allowed to define what an incident was. Now they are, as shown here, a cybersecurity incident is a malicious act, suspicious event. It was a compromise or an attempt to compromise the electronic perimeter or the physical perimeter. Or it disrupted or was an attempt to disrupt some level of cyber asset. A reportable cybersecurity incident is something that has done those things above, and it's done them in a way where it's impacted a reliability task, meaning power generation, dynamic response, voltage control, balancing, situational awareness, all the things that the operators do using those tools, using those cyber assets, using those digital components. If the digital components are disrupted, compromised, and attacked, but it doesn't cause a reliability impact, then it's not a reportable cybersecurity incident under these two current definitions. So to show you that in pictures, for those who are not really familiar with these definitions or North American electric regs, if there was a compromise of a physical perimeter, somebody broke into a control center or an electronic security perimeter, they breached the firewall, and they actually disrupted the BES bulk electric system cyber assets, that is for sure a cybersecurity incident. But if it did not cause any effect on power generation, dynamic response, any type of situational awareness or balancing, or any of the control center functions, then it wouldn't have been reportable. And this is something that FERC had concerns around. And there's been a lot of conversations along this line of, if we're not getting reporting until something obvious happens, that seems like something we should expand on. That seems like something we should pursue further. And conversations would occur along the lines of how many reportable cybersecurity incidents have happened to date. And if the answer continues to be 0, and then at the same time, other Intel organizations or other events are happening that would seem to lead to believe that there should be more things being reported, this level of concern just continued to grow. So in light of that, when there's a problem, usually regulation will come to fix it. And this change is coming starting January 1st next year. So this new CIP-008 will be coming, and it will impact all electric sector asset owners and operators within the bulk electric system of North America. The additional changes here is the reporting component, where you will now be reporting compromise or an attempt to compromise, where before that reporting wasn't required. You will need to include a minimum reporting detail, a couple of different reporting timelines. And in addition, you are not just reporting to the Electric Sector Information Sharing and Analysis Center, you are also now reporting it to DHS NCIC. With those reports, NERC has been tasked with developing summary reports up to FERC on a frequency. So looking at some of the items here, the initial notification needs to include the functional impact, which some may or may not know, depending on what the attack is. The attack vector used. In some cases, that could take weeks or months to determine. The level of instruction achieved or attempted. And that is a place where there is a lot of ambiguity. Because if something was attempted, you don't know from the adversary perspective what their ultimate goal or target was. So determining what that was, it could be difficult. The initial notification within 1 hour of reportable cybersecurity, or the next day if it was just an attempt. And then continuous updates every 7 days of learning something new. So predicting the future here in my last couple of slides, if this is a normal network architecture, entities are going to either develop a very, very specific definition of what the term attempt is, because it's not defined for them. So there's going to be a very focused definition in their own policies of what an attempt is. Or there will be an approach that I've called a firewall sandwich. So there will be new firewalls implemented outside of the in-scope firewalls that will have the same rule sets. They're truly providing no additional cybersecurity capability. It's just a new perimeter that any misconfigured device, any type of attempt, any type of an alert that occurs at those outer firewalls that are not in scope of this standard, those would not require reporting. If it's allowed through that firewall to the next, and then it's a attempt that is rejected, denied, it's a scan, it's a probe, it's generally something you would want to filter out at the layer above. But if it does in fact get down to that next layer, then it would trigger that the next element, which is how does the entity define the attempt word. And last, without taking either one of those steps of either a really specific definition of attempt or some type of firewall sandwich architecture modification, the result would be a very, very confused industry with lots and lots of reports going to the NCIC of every single attempt, every single scan, every single deny, or lots and lots of research and teams going out to validate or verify whether something was an attempt or whether it was a misconfiguration. Tons of noise will generate for this, and it's going to be an environment that we all have to kind of mature in and understand what this means. There's one last thing that I have to mention. I know we're at time, but today a new executive order to secure the U.S. bulk power system was signed. There's some things here that are going to take some time to walk through. So for certain, this is a focus kind of on suppliers and hardware and software that is used within bulk power throughout the United States. There is already a NERC regulatory standard for those same asset owners and operators and vendors and the stakeholder community that is coming into effect, which is CIP-008. There's going to need to be some review of any level of conflict or any level of duplication or concern across those two different directives. Also, there's going to need to be some understanding of the intent and scope around achieving this implementation. Whether it's for new systems coming in, it's for existing systems, how existing systems can be kind of moved into the intent of this executive order. What this means for non-bulk power system assets, so things that do not meet the threshold of 100 kV and above from a transmission level or from a generation capacity. However, they're still connected to that same common system if this has any downflowing impacts against those equipment vendors, hardware or software components. The cyber operational components, this is certainly where there's going to be a lot of discussion. Is this purely targeting and meant around transformers, which some of them have cyber digital components and controls directly tied? Is it around generation assets and specifically the suppliers of the physical components or the controls components as well? And throughout the order, there is some references to monitoring, which would lead you back towards some of the cyber assets that are used to operate these types of assets. Last, our electric system doesn't stop at our border. So this executive order applies to US, but we are interconnected across Canada and parts of Mexico that we will need to understand what that means for other parts of our bulk electric system, bulk power system that are not US, and for what it means for some unique conditions where you have foreign asset owners or operators in control of assets within our borders. Looking towards the cyber components and the monitoring components and kind of especially down in the bulk power system areas, there's some reference on the Department of Energy site to a kind of development of a vendor list or a provider list. And it's going to be very, very interesting to see where that goes in regards to which countries might be on the not approved list, how far they go in regards to where a company is headquartered versus where the hardware is manufactured versus where the software comes from. Our supply chain across this environment is very, very complex, and developing an approved provider list and an approved country can get very, very challenging as those who are on this call that are here because they know Dragos or they're here because they know SANS. Products and the platform that Dragos makes, I believe they are, and Rob can confirm this, but I've looked across kind of this suite of vendors. I believe they're the only ones that are US. So depending on where this goes from the perspective of provider lists and provider countries, it could be a very good day to be Dragos. But a lot remains on this. It just came out today, so the entire industry is going to be watching it. With that, I think I am at time. My contact information is here. All these sessions are recorded for those who joined late.